In this video, we'll be going over the recursive approach of binary tree preorder traversal. So given the root of a binary tree, return the preorder traversal of its node values. Let's go over the dot process. So we will be implementing a recursive approach. Let's first go over the direction of a preorder traversal. So the direction is roots and then left subtree and then right subtree. Okay, we can implement the pseudocode. So let's implement the recursive approach. And then before that, we're gonna create a list values to keep track of all of the node values. And then we're gonna implement the recursive approach. And then what parameters do we need? We will need the node, the current node we are visiting, and then values, the list of all node values. And then what's the base case? If the current node is null, this means there's no value here, so we can just return from the recursive call. Then in each of the recursive call, we're going to add the current node.val to values because we got to visit the root first. And then we're going to recursively visit the left subtree because the next node is in the left subtree. So visit node to node.left. And then we're going to recursively visit the right subtree, node to node.right. Then we can return values. Let's go over the time and space complexity. For the time complexity is O of n, where n is the number of nodes in the input tree. We visit each node once. And our space complexity is O of n plus O of h. So we get O of n. So where n is the number of nodes in the input tree, and h is the height of the tree. This is for our values list, and O of h is our recursive call stack memory. Now let's go over to code. So we're first going to create our list to keep track of all values. Then we're going to implement our recursive preorder traversal, passing our roots and our values list, and then we can return values after we finish our traversal. We're going to pass in our current node and also the list of values. We'll first go over the base case. If node is equal to null, this means there's no value here, so we can just return from the recursive call. Then in each of the recursive call, we want to add the current node value to values first, and then we want to traverse to the left and right subtrees. So we want to traverse to the left subtree, and then traverse to the right subtree. Then we can, then this is it. Let me know if any questions in the comment section below.